Welcome to this comprehensive guide on Claude Code. Before we dive in, consider this. According to GitHub's own research, developers using AI coding assistants complete tasks up to 55% faster than those working without them. That is not a marginal improvement. That is a fundamental shift in how software gets built. We are standing at an inflection point in software engineering history. The question is no longer whether AI will be part of your development workflow, but rather which tools you will master and how deeply you will integrate them. In this lecture series, we are going to explore one of the most powerful and architecturally unique AI coding tools available today, Claude Code by Anthropic. By the end of this series, you will have the knowledge and confidence to use it like a professional. So where does Claude Code fit into this landscape? Claude Code is Anthropic's flagship agentic coding assistant, and it is unlike most AI tools you may have encountered. While many AI coding assistants operate as plugins inside your editor, Claude Code runs directly in your terminal. It is a command-line interface tool that can read your entire codebase, execute shell commands, run tests, manage files, and reason through complex multi-step engineering tasks autonomously. Anthropic, the company behind it, was founded former OpenAI researchers with a strong focus on AI safety and reliability. That philosophy is baked into Claude Code. It is designed to be not just capable, but trustworthy and transparent in how it operates. Think of it less as an autocomplete engine and more as a senior engineering colleague who lives in your terminal. Now let us take a moment to map out exactly what you will learn across this full lecture series. This is your roadmap. We begin here in Chapter 1, the big picture, understanding why Claude Code exists and where it fits in the AI tools ecosystem. In Chapter 2, we deep into its core concepts and architecture, how it actually works under the hood. Chapter 3 covers installation and configuration so you can get it running on your own machine. Chapter 4 is where it's get exciting, real-world usage patterns and advanced workflows. Chapter 5 explores team collaboration and integration with CI/CD pipelines. And finally, Chapter 6, best practices and what the future holds for agentic AI development. Each chapter builds on the last, so stay with us through the entire journey. Let us now define Claude Code with precision. At its core, Claude Code is an agentic AI coding tool. The word agentic is critical here. It means the tool does not just respond to a single prompt and stop. Instead, it can take a goal, break it down into subtasks, execute those tasks sequentially using real tools like bash commands and file system access, observe the results, and adjust its approach dynamically. You interact with it through a terminal command. Simply typing Claude in your project directory launches an interactive session. From there, you can ask it to implement a feature, debug an error, write tests, refactor legacy code, or even explain an unfamiliar codebase. It operates with a high degree of autonomy, while keeping you informed and in control every step. This is what separates it from simple code completion tools. Now, you might be asking, how is Claude Code different from GitHub Copilot or Cursor, which I may already be using? That is an excellent question, and the answer reveals a lot about Claude Code's design philosophy. GitHub Copilot is primarily an inline code completion tool. It lives inside your editor and suggests the next few lines as you type. It is reactive, not proactive. Cursor is an AI-enhanced IDE. It wraps VS Code, adds AI features like code-based search and chat, but it is still fundamentally editor-bound. Claude Code, by contrast, is editor-agnostic and terminal-native. It operates at the project level, not the Cursor level. It does not just predict your next line. It can plan, execute an entire feature implementation across multiple files, run your test suite, fix the failures, and commit the result. These are fundamentally different categories of tool. To wrap up this introduction, let us crystallize the takeaways before we move into the deeper technical chapters. Claude Code occupies a unique position in the AI developer tools ecosystem. It is not trying to compete with Copilot on autocomplete. It is playing an entirely different game. Its differentiators are clear. It is agentic, meaning it can act across multiple steps. It is terminal native, meaning it fits into any workflow regardless of your editor. And it is built on Claude, one of the most capable and safety-conscious large language models available today. As we move into Chapter 2, we will open up the hood and explore the architecture that makes all of this possible, the agent loop, the tool use framework, and how Claude reasons through complex coding problems. Get ready to go deep. Welcome back. In our previous chapter, we explored how AI-assisted development is transforming the software engineering landscape. Let's go deeper and understand exactly what powers Claude Code under the hood. At its core, Claude Code is built on Anthropic's Claude large language model, specifically Claude 3.5 Sonnet and its successors, which are among the most capable models available for reasoning about complex code. A large language model, or LLM, is a neural network trained on vast amounts of text and code data, enabling it to understand natural language instructions and generate syntactically correct, semantically meaningful code. What sets Anthropic's Claude models apart is their emphasis on helpfulness, harmlessness, and honesty, a design philosophy called constitutional AI. For developers, this means Claude Code doesn't just generate code blindly. It reasons about your intent, considers edge cases, and can communicate its uncertainty. Understanding that Claude Code is fundamentally an LLM with specialized tooling is the mental model you need to use it effectively. Now that we understand the AI model powering Claude Code, let's explore one of its important architectural concepts, the agentic loop. Traditional AI assistants respond to a single prompt and stop. Claude Code operates differently. It runs in an autonomous agentic loop. Here is how it works. First, Claude receives your high-level task, such as fix the authentication bug in the login module. Second, a series of sub-steps to accomplish that goal. Third, it executes those steps using built-in tools, reading files, running commands, writing code. Fourth, it observes the results of each action. Fifth, it self-corrects if something goes wrong, replanning as needed. And finally, it reports back to you when the task is complete or when it needs your input. This loop can run for dozens of iterations on a complex task, much like how a skilled developer works through a problem methodically. The agentic loop is what transforms Claude Code from a simple chatbot into a genuine autonomous coding agent. The third foundational concept you must understand is the context window and how Claude Code uses it to comprehend your entire codebase. A const window is the total amount of text, code, instructions, conversation history that the model can read and reason about at one time. Claude's context window is exceptionally large, allowing it thousands of lines of code simultaneously. When you point Claude Code at your project, it actively reads and indexes relevant files, source files, configuration files, README documents, loading them into its context. This is what allows Claude to give answers that are aware of your specific project structure rather than generic boilerplate. However, context windows are finite, so Claude Code is smart about which files it prioritizes based on relevance to your current task. Understanding this helps you work better with Claude Code. Providing good project structure and clear file organization helps Claude find the most relevant context quickly and efficiently. With the foundational concepts clear, let's now look at the technical architecture of Claude Code, specifically the tools it can invoke to take real actions in your development environment. Claude Code exposes a set of built-in tools through Anthropic's Tool Use API. Think of these tools as the hands and eyes that allow the AI brain to interact with the real world of your computer. The first and most powerful is the bash tool, which allows Claude to execute arbitrary shell commands, running test suites, installing packages, compiling code, starting servers. Second is the file edit tool, which enables Claude to read and write files directly in your project, creating new modules, modifying existing functions, deleting obsolete code. Third is the web search tool, which lets Claude look up current documentation, research error messages, or find the latest API references without leaving your terminal. These tools collectively make Claude a full-stack development agent, rather than just a text generator. Every action it takes goes through this structured tool call mechanism, making its operations transparent and auditable. With great power comes great responsibility, and Claude Code's designers at Anthropic took this seriously. Claude Code operates under a carefully designed permissions and safety model that governs which actions it take autonomously and which require explicit user approval. By default, Claude Code will ask for your confirmation before performing potentially irreversible or high-impact actions, such as deleting files, making commits to your repository, or executing network-affecting commands. This human-in-the-loop design ensures you always maintain control. For lower-risk actions like reading files or running unit tests, Claude can proceed autonomously without interrupting your workflow. You can customize these permission thresholds using configuration flags. For example, passing the -dangerously skip permissions flag in fully automated CI/CD pipelines where no human is present. The key principle is safe execution by default with opt-in autonomy, balancing productivity with safety in real-world development environments. The final architectural concept in this section is one of the most practically useful features of Claude Code, the KeyLayout file. Think of KeyLayout as a persistent memory and instruction manual that lives in your project repository. When Claude Code starts a session in your project directory, one of the first things it does is look for and read the KeyLayout file. Inside this file, you can place any project-specific instructions you want Claude to always follow, your coding conventions, the commands needed to build and test your project, architectural decisions, which files to avoid modifying, or team-specific guidelines. For example, You might always use TypeScript strict mode or run npm test before committing any changes. This means you don't have to re-explain your project context every time you start a new session. Claude effectively gives Claude Code project-level memory, making it dramatically more useful on long-lived, real-world codebases compared to a stateless AI assistant. To truly appreciate where Claude Code stands today, it helps to understand how it evolved. Anthropic began as an AI safety company in 2021 by former OpenAI researchers, and their early work focused on large language model safety and alignment research. Claude 1 was released in early 2023, demonstrating strong reasoning capabilities but lacking agentic tooling for developers. That same year, Claude 2 introduced a dramatically expanded context window, up to 100,000 tokens, which was a game-changer for processing large codebases. In early 2024, Claude 3 arrived as a model family with 3 tiers: Haiku for speed, Sonnet for balance, and Opus for maximum capability. Claude Code itself was launched publicly by Anthropic in 2024 as a command-line tool built on top of these models, initially in limited beta and then broadly available. Claude 3.0 Sonnet followed as an update that significantly outperformed prior versions on coding benchmarks like SBOE Bench, cementing Claude Code's position as a leading agentic coding assistant. This rapid evolution reflects the explosive pace of the entire AI-assisted development field. Let's take a moment to consolidate everything we've covered in this chapter before we move forward. We started by establishing that Claude Code is built on Anthropic's Claude large language model, with Claude 3.5 Sonnet as its primary engine. We then explored the agentic loop, the plan, execute, observe, and self-correct cycle that makes Claude Code behave like an autonomous developer rather than a simple chatbot. We examined how Claude Code uses its large context window to read and index your codebase, enabling genuinely project-aware assistance. On the architectural side, we covered the 3 core tools: Bash execution, file read and write, and web search. We looked at the permissions model that keeps dangerous actions under your control, and we introduced Claude as the mechanism for giving Claude persistent, project-level memory. Finally, we traced the historical evolution that brought Claude Code to where it is today. In our next chapter, we will leave the theory behind and get hands-on, walking through how to install, configure, and navigate Claude Code for the very first time in your own development environment. Welcome to Chapter 3. In the previous chapter, we explored the core concepts and architecture that make Claude Code such a powerful agentic coding assistant. Now it's time to get hands-on. Before you can use Claude Code, you need to ensure your environment meets the prerequisites. Claude Code is distributed as an NPM package, which means you know Node.js version 18 or HEN or higher installed on your system. This applies whether you're on macOS, Linux, or Windows. Once Node.js is ready, installation is a single command: npl Anthropic Claude Code. The flag installs it globally, making the Claude command available from any directory in your terminal. On macOS and Linux, this works seamlessly in your standard terminal. Windows users use PowerShell or WSL, the Windows subsystem for Linux, for the best experience. After installation completes, you can verify it by running Claude version to confirm everything is set up correctly. With Claude Code installed, the next critical step is authentication. Claude Code connects to Anthropic's API under the hood, and for that it needs a valid API key. To obtain one, navigate to consoleanthropic.com, create or log into your account, and generate a new API key from the API keys section. Keep this key secure, treat it like a password. There are 2 primary ways to provide the key to Claude Code. The recommended approach for development is setting the environment variable Anthropic API key in your shell profile, for example in your bashik or zishko file using export Anthropic PI key to your key here. The second approach is passing it directly as a CLI flag using API key, though this is less secure for regular use since the key may appear in your shell history. For team or CI environments, use secret management tools like AWS Secrets Manager or GitHub Actions Secrets. Once the key is configured, simply run Claude in your terminal. If authentication succeeds, you'll see the interactive prompt appear, confirming you're ready to start coding with Claude. Now that Claude Code is installed and authenticated, let's explore the core CLI commands and configuration flags you'll use every day. The simplest way to launch Claude Code is just typing Claude in your terminal inside a project directory. This opens the interactive session. You can also pass a task directly as a string argument. Claude, refactor the authentication module for quick one-shot tasks. Print or P flag outputs results to stout without entering interactive mode, which is essential for scripting. The model flag lets you specify which Claude model to use. For example, Claude 3.5 Sonnet de 0 You can set the number of tokens with max tokens and use no stream if you need complete responses rather than streamed output. For verbosity and debugging, Verbose gives you detailed logs of every tool call Claude makes. These flags can also be combined. For instance, running Claude Code in a shell script with p and model together is a common pattern for automated code review pipelines. Understanding these flags gives you full control over how Claude Code behaves in any context. Understanding how to interact effectively with Claude Code in its interactive terminal mode is the skill that separates basic users from power users. When you launch Claude Code inside a project directory, it reads your file system context and is ready to receive natural language task instructions. The key insight here is that Claude Code works best when you delegate complete, well-defined tasks rather than issuing single-line commands. Instead of saying write a function, say write a Python function that parses JSON from an API response, handles missing keys gracefully, and includes unit tests. The more context you provide about the expected behavior, the better the output. You can also ask Claude to explore before acting. Phrases like first explore the codebase structure, then implement, trigger the agent's tool use capabilities in a controlled, deliberate sequence. During an interactive session, Claude Code will show you each step it takes, ask for confirmation on destructive actions like file deletions, and present results in line. Think of it as pair programming with a senior engineer. You direct the strategy, Claude executes the implementation details. Beyond interactive mode, Claude Code supports a powerful set of slash commands and a headless execution mode that makes it ideal for automation. Inside an interactive session, slash commands give you quick access to special behaviors. For example, help lists all available commands, clear resets the conversation context, shows the token usage and estimated cost for the current session, and review triggers a code review of recent changes. Headless mode, activated the p or print flag, allows Claude Code to run entirely non-interactively. It receives a prompt, executes the task, prints results to standard output, and exits. This is exactly what you need for CI/CD integration. Imagine a GitHub Actions workflow that runs Claude PA. Check for security vulnerabilities in changed files. On every pull request, the output can be captured, parsed, and posted as a PR comment automatically. You can also pipe input into Claude Code using standard Unix piping, cat error log, type Claude, diagnose and suggest fixes. This composability with standard shell tools is what makes Claude Code a first-class citizen in any developer automation toolkit. One of the most important aspects of working with Claude Code effectively is understanding how it manages conversation context within a session. Each time you launch Claude Code, a new session begins. Within that session, Claude maintains a running context of everything discussed, your prompts, its responses, and the results of every tool call. This is what enables you to ask follow-up questions, like now add error handling to that function, without re-explaining the entire situation. However, context has a finite limit, the model's context window. When sessions grow very long, you may notice responses becoming less precise. The clear slash command resets this context, giving you a fresh start without restarting the process. For longer projects, it's good practice to break work into logical sessions, complete one coherent task per session. Claude Code also supports session resumption through conversation IDs in certain configurations, allowing you to pick up a previous thread. As we move into the next section on configuration files, you'll see how Claude helps maintain persistent project context across multiple sessions automatically. Now we come to one of the most powerful and often underutilized features of Claude Code, the Claude file. This is a markdown file you place at the root of your project repository, and Claude Code automatically reads it at the start of every session. Think of it as a persistent briefing document that tells Claude everything it needs to know about your project before you type a single prompt. A well-structured Claude typically contains several key sections. A project overview describing what the code base does and its tech stack. Coding standards defining profiling naming conventions and formatting rules. Architecture notes describing the folder structure and key modules, preferred libraries and frameworks to use or avoid, and common commands like how to run tests or start the development server. By encoding this knowledge in Claude, you eliminate the need to re-explain your project context in every session. Claude Code will respect these instructions throughout all interactions. You can also place Claude files in subdirectories for module-specific instructions, and Claude Code will read all relevant files based on the current working directory. Let's look at a concrete example of what this file should contain. Having seen what a Claude file looks like, let's cover the best practices for writing and maintaining one effectively. First, keep it actionable. Claude Code reads this file on every session, so avoid lengthy prose. Use bullet points and short sentences. Second, be specific about what to do and what to avoid. Vague instructions like clean code are far less useful than use ESLint with the airbbb config, and never use var. Third, since Claude is just a markdown file, It belongs in version control alongside your source code. Commit it to your repository so the entire team benefits from the same Claude behavior. This is especially powerful on teams. Once a senior engineer writes the initial Claude MMD, every team member gets Claude Code behavior aligned with project standards automatically. Fourth, treat Claude MMD as a living document. Update it when architecture decisions change, new libraries are adopted, or coding standards evolve. Finally, use nested Claude MMD files strategically. Place a root-level file for project-wide rules and subdirectory files for module-specific context like directory contains legacy code. Refactor cautiously. As we move into Chapter 4, you'll see how these configuration fundamentals unlock the full depth of Claude Code's features and capabilities. Now that you have Claude Code installed and navigated through its interface, let's dive deep into what makes it truly powerful. The first and most immediately impressive capability is autonomous code generation. You describe a feature in plain English, and Claude Code writes production-ready code, including the implementation, error handling, and tests, all in one shot. For example, simply typing create a rate-limited API client with retry logic and exponential backoff produces a fully structured module. Claude Code analyzes your existing codebase style, matches naming conventions, and generates code that feels native to your project. This is not just autocomplete. It's full-feature implementation from a single natural language prompt. One of Claude Code's standout capabilities is multi-file refactoring. Traditional tools refactor within a single file, but real-world codebases require changes that ripple across dozens of files. Claude Code traces dependency graphs, identifies every location where a function, class, or variable is referenced, and applies consistent transformations everywhere simultaneously. For instance, renaming a database model and updating all its serializers, views, migrations, and tests in one atomic operation. The agent reads your project's import structure, understands the call hierarchy, and ensures that no reference is left inconsistent. This turns hours of manual refactoring into a single conversational command. Let's compare Claude Code's AI-driven code review with traditional static analysis tools like ESLint, PyLint, or SonarQube. Traditional linters are rule-based, syntax errors, style violations, and known anti-patterns extremely fast and reliably. But they cannot understand intent. Claude Code, on the other hand, reviews code semantically. It spots logic errors, identifies security vulnerabilities in context, flags misleading variable names, and suggests architectural improvements. Importantly, these two approaches are complementary, not competing. Use linters for fast, deterministic enforcement of standards, and use Claude Code for deeper semantic review that understands what your code is supposed to do. Together, they form a comprehensive quality gate. Debugging is where Claude Code's agentic loop truly shines. When you encounter an error, you can paste the stack trace directly into the terminal, and Claude Code begins an autonomous diagnosis cycle. First, it reads the error output and forms hypotheses about the root cause. Then it examines the relevant source files, checks variable states, and traces the execution path. It applies a targeted fix, reruns the failing command, and evaluates the new output. If the error persists, or a new error appears, it iterates, repeating the red hypothesize fix verify cycle until the issue is resolved. This mirrors exactly how a senior engineer debugs systematically, but at machine speed. Test coverage is a persistent pain point for development teams. Writing tests is time-consuming and often deprioritized. Code eliminates this friction by generating comprehensive unit and integration tests automatically. Given a function or module, it analyzes all code paths, edge cases, boundary conditions, and error states, then produces a complete test suite. Notice in this example how Claude Code generates not just the happy path test, but also tests for empty inputs, type errors, and exception handling. It follows your project's existing test framework, whether that's PyTest, Jest, Mocha, or JUnit, and matches your existing test style. This dramatically increases coverage with minimal developer effort. CI pipeline failures can block an entire team. With Claude Code, resolving these failures becomes a structured, autonomous process. You simply provide the failing test output from your CI system, GitHub Actions, Jenkins, or GitLab CI, and Claude Code reads the test names, failure messages, and assertions. It then navigates to the relevant source code, understands what behavior the test expects versus what the code actually produces, and implements the fix. This capability is especially powerful for catching regressions introduced by recent commits. In the next chapter, we'll see exactly how to integrate this into real-world team workflows, making Claude Code a permanent part of your CI-driven development cycle. Documentation is one of the most universally neglected aspects of software development. Developers under deadline pressure skip docstrings, leave modules undocumented, and let README files go stale. Claude Code addresses this directly. Point it at any function, class, or module, and it generates accurate, context-aware inline documentation. It reads the code logic to understand what parameters actually do, what values are returned, and what exceptions might be raised, producing doc strings that reflect the real behavior. Beyond inline docs, Claude Code can generate full README files, API references, and usage guides for entire projects. This means your documentation stays synchronized with your actual code, not what you hoped to write 6 months ago. Finally, let's talk about codebase understanding, perhaps the most underrated feature for developers joining a new project. When you encounter an unfamiliar codebase with hundreds of files and no documentation, onboarding can take weeks. Claude Code performs semantic search across your entire project, allowing you to ask architectural questions in plain English. Where is authentication handled? Which modules write to the database? Or how does a user request flow from the API to the response? Claude Code doesn't just search for keywords, it reasons about code structure, traces data flows, and constructs a coherent mental model of the architecture. This transforms weeks of exploration into minutes of conversation, setting the stage perfectly for the real-world workflow strategies we'll cover in our next chapter. Now that we've explored Claude Code's key features and capabilities in depth, let's shift our focus to how these features translate to real-world developer workflows. One of the most powerful integrations is with Git. Claude Code can handle the entire lifecycle of a feature implementation, from creating a new branch to writing the code, committing the changes with a meaningful commit message, and even opening a pull request on GitHub or GitLab. Imagine telling Claude Code, create a new branch called feature user auth, implement JWT-based authentication in the auth module, commit the changes, and open a pull request targeting the main branch. Claude Code will execute each of these steps sequentially, treating your Git repository as a first-class citizen. This dramatically reduces the context switching overhead developers normally face when jumping between their editor, terminal, and browser. Beyond local development, Claude Code can be embedded directly into your CI/CD pipelines. A particularly powerful use case is automated code review and patch generation triggered on every pull request. Using GitHub Actions, you can configure a workflow that invokes Claude Code via the Anthropic API when a PR is opened or updated. Claude will analyze the diff, identify potential bugs or style violations, and can even push a corrective patch commit back to the branch. Here's what a minimal GitHub Actions workflow for this looks like. The workflow is triggered on pull request events, checks out the repository, installs the Claude Code CLI, and runs a review command against the changed files. This creates a fully automated quality gate that supplements, never replaces, your human reviewers, catching trivial issues before they waste code review time. The third integration pattern worth understanding is IDE pairing. You have two primary ways to work with Claude Code: running it standalone in your terminal as a fully autonomous agent, or pairing it with an IDE extension like the VS Code extension. Each approach has distinct strengths. The terminal-only mode is ideal for long-running autonomous tasks, bulk refactoring, multi-file migrations, or CI environments where there is no GUI. The IDE paired mode, on the other hand, gives you real-time inline suggestions, visual diffs, and the ability to accept or reject individual changes with a single click. For most developers, the sweet spot is using both in combination. Kick off large automated tasks from the terminal, then switch to the IDE for fine-grained review and editing. This hybrid maximizes productivity without sacrificing control. The quality of Claude Code's output is directly proportional to the quality of the instructions you give it. This is why prompt engineering is not just an optional skill. It is a core competency for any developer using AI coding tools. There are several foundational principles that consistently produce better results. Always provide rich context. Tell Claude which language, framework, and version you're using. Second, define the task scope precisely. Specify what files to touch and what to leave unchanged. Third, state your acceptance criteria. What does done look like? Should it pass specific tests? Fourth, provide examples when possible. A sample input and expected output eliminates ambiguity. Fifth, specify constraints like performance requirements or coding style guides. And finally, instruct Claude on what NOT to do, which is often as important as what to do. These 6 principles form the foundation of effective prompting. To make these principles concrete, let's look at a direct side-by-side comparison of poorly written versus well-structured prompts. On the left, a vague prompty. Add authentication to my app. This gives Claude almost no useful information. What kind of authentication? Which files? What framework? The result will be a generic, likely incorrect implementation that requires significant rework. On the right, a precise prompty. In the Fast API application located in AppAPI, add JWT-based authentication to the user's endpoints only. Use the Python JOSA library which is already installed. Do not modify the existing user model in model's user prepay. The login endpoint should accept email and password and return an access token valid for 24 hours. Refer to our existing auth pattern in app auth for style consistency. This prompt gives Claude everything it needs to produce production-quality code on the first attempt. Specificity is not pedantry, it is efficiency. Even with a perfect initial prompt, Claude Code's output will sometimes be partially correct. Maybe the logic is right, but the error handling is missing, or the tests don't cover edge cases. The key insight here is, don't start over. Iterative refinement is far more efficient. Follow a structured correction strategy. First, acknowledge what's correct. Tell Claude which parts to keep. Second, the specific deficiency, rather than redescribing the whole task. Third, use the output as context. Paste the generated code back, and say given this implementation, now add X. Fourth, ask Claude to explain its reasoning when outputs are unexpected. This often reveals a misunderstanding you can correct with one clarifying sentence. This iterative loop, prompt, evaluate, refine, is the professional workflow. Mastering it separates developers who get 10x value from Claude Code from those who get frustrated and give up. This skill will carry directly into the next chapter where we wrap up with key takeaways. As you scale your use of Claude Code, two practical concerns rise to the top: cost management and responsible usage. Let's tackle cost first. Claude Code's pricing is driven by token consumption, both input tokens, which include your prompt and the code-based context you provide, and output tokens, which are the generated code and responses. Different task types consume very different amounts of tokens. A simple function generation task might use a few hundred tokens, while a full agentic session involving multi-file refactoring with test execution can consume tens of thousands. Anthropic offers different model tiers. Claude is the fastest and cheapest, ideal for high-volume repetitive tasks like linting or documentation. Claude Sonnet balances capability and cost for most development tasks. Claude Opus is the most capable and most expensive, reserved for complex architectural decisions and difficult debugging sessions. Matching the right model tier to the right task type is the single most effective cost optimization strategy available to you. Beyond cost, responsible use of AI-generated code is a professional obligation. The speed and fluency of Claude Code's output can create a false sense of confidence. Code that reads well is not necessarily code that is correct, secure, or suitable for your specific context. There are several non-negotiable safety practices every team should adopt. Always review AI-generated code before merging. Never commit AI output blindly, even for trivial changes. Never include sensitive data in your prompts. No APIs. No personally identifiable information. No proprietary business logic that violates your organization's data governance policy. Maintain human oversight in your pipeline. AI is a tool that augments your judgment, not one that replaces it. Audit AI-generated code specifically for common security vulnerabilities like SQL injection, insecure deserialization, and hard-coded credentials. And finally, document AI-assisted contributions in your code reprocess, so your team has full visibility into where AI was involved. As we prepare to wrap up in our final chapter, remember, the goal of Claude Code is to make skilled developers faster, not to replace the skill itself. And that brings us to the final chapter of our complete guide to Claude Code. I've covered a tremendous amount of ground together, so let's take a moment to consolidate everything you've learned. We started by understanding what Claude Code is: an agentic, terminal-native AI coding assistant built on Anthropic's Claude model, capable of reading, writing, and executing code directly in your development environment. We then walked through installation and configuration, covering API key setup, global settings, and how to tailor Claude Code's behavior using the key layout file. From there, we explored its core feature set: multi-file editing, shell command execution, web search integration, and the powerful extended thinking mode for complex problem solving. We saw how Claude Code handles entire workflows autonomously, from generating boilerplate and writing tests to debugging runtime errors and reviewing pull requests. And in our previous chapter, we brought it all together with real-world workflows and best practices, including how to structure prompts effectively, when to use headless mode for automation pipelines, and how to integrate Claude Code safely into team environments. This full-stack knowledge gives you everything you need to become a confident and productive Claude Code user. Now, as we close this section, I want to leave you with one guiding principle that should anchor your entire journey with AI-assisted coding. The developers who get the most out of tools like Claude Code are not those who try to hand off all thinking to the AI. They are the ones who stay sharply in the driver's seat, using Claude Code as a force multiplier for their own expertise. Claude Code is extraordinarily capable, but it is at its best when paired with a developer who understands the problem domain, reviews outputs critically, and iterates with intention. Think of it less like autopilot and more like a highly skilled co-pilot who never gets tired. Your judgment, your architecture decisions, your code review instincts, those remain irreplaceable. Embrace Claude Code not as a replacement for engineering thought, but as an amplifier of it. That mindset shift is what separates developers who dabble with AI tools from those who genuinely transform their productivity. So, what should you do right now, today, to start putting Claude Code to work? Let me give you a concrete action plan. First, if you haven't already, install Claude Code via npm and authenticate with your Anthropic API key. Get it running in a project you're actively working on, even if it's something small. You can create your first Claude file in that project. Document your stack, your conventions, and any constraints Claude Code should respect. This single file will dramatically improve the quality of every interaction you have. Third, try tackling a real task end-to-end. Ask Claude Code to write a feature, generate tests for it, and then review the output as if it were a junior developer's pull request. Fourth, explore the official Anthropic documentation at docsanthropic.com. The Claude Code reference section is thorough and regularly updated. Fifth, join the Anthropic developer community on Discord and forums like Reddit's rClaude AI, where practitioners share prompts, patterns, and discoveries daily. And finally, challenge yourself with a personal project where Claude Code handles the scaffolding while you focus on the design and business logic. Hands-on practice is irreplaceable. The more you use it, the more intuitive it becomes. Finally, let's zoom out and look at where all of this is heading. We are at a genuinely historic inflection point in software engineering. Tools like Claude Code represent the first generation of truly agentic AI coding assistants. Systems that don't just autocomplete a line of code, but that can reason across entire code bases, execute multi-step plans, and operate autonomously over extended sessions. Looking ahead, we can expect several major developments. Agentic AI will become deeply embedded in CI/CD pipelines, automatically triaging bugs, writing patches, and opening pull requests without human initiation. Multi-agent systems, where specialized AI agents collaborate on different parts of a codebase simultaneously, are already emerging and will become mainstream. The role of the software engineer will continue to evolve. Less time on routine implementation, more time on system thinking, product decisions, and creative problem solving. Claude Code and its successors will grow more capable, more context-aware, and more deeply integrated with the tools we use every day. The developers who invest in understanding and mastering these tools today will be the ones defining how software is built tomorrow. Thank you for joining me throughout this complete guide to Claude Code. Now go build something remarkable.